All right, so our next example is about compound interest, which is really just the same problem again, right? Only now we're calling P of t the future value, and P0 is our initial investment, and K is our interest rate. So for instance, if I say you invest $4,000 at an annual interest rate of 2.5% compounded continuously, what's the function? You say, okay, great, I got this, right? Because 4,000, that's going to be our P0. That's our initial investment, and we see that continuous compounding. So e to the 0.025t. There we go. That's all that there is to it. How much are we going to have in 10 years? Plug in 10, right? $4,000 e to the 0.025 times 10. We'll go see how much that is in our trusty Algebra calculator. There we are. So 4,000 times e to the 0.025 times 10. We are something, oh, you know, can't use e now. That's the problem. So I'm going to have to say exp of 0.025 times 10. There we go, 51.36 and 10 cents. There we go. So not too bad, right? This is plug and chug, basically. So this is a little bit different, right? This is given the pieces of information, find the other parts, right? So if we have an initial investment of $5,000 and after 5 years we know we have $71.30 and 90 cents, we got to figure out the interest rate, right? So we know our formula, 5,000 e to the kt, and these are continuous compounding, right? We know after 5 years we have 7130.9 e to the 5k. And so we need to solve this for k, right? So we're going to start by dividing both sides by 5,000. So 7130.90 over 5,000 will be e to the 5k. And then we need to get the k out of the exponent, right? So we're just going to take the natural log of both sides. So ln 7130.90 over 5,000. So we take the natural log of both sides. The ln of e to the 5k, we can pull the 5k around front from the power rule. ln of e is 1. And so last but not least, we're going to divide both sides by 5. I'm going to write it over here. So we've got ln 7130.90 over 5,000, divide by 5. There is our k. And we've got to go plug that in because I don't have the foggiest clue what that is. Let's do this. There we go. All right. Okay, so we've got the natural log, 7130.90 over 5,000, and then we're going to divide that by 5. That is going to give us our k, 0.0709999. So we'll call that 0.071. All right, so 0.071, so we could say 7.1%. What is our doubling time? We're going to remember that that is ln 2 over k. So ln of 2 over 0.071, which again we got to go do in our calculator. Natural log of 2 over 0.071. So doubling time 9.7626. And that's going to be years, right? And we know it's less, and we know it's more than 5 because we hadn't doubled yet. Okay, so the second part of this one is actually a little bit easier. We don't know how much money we initially invested. We do know how much we have after 5 years, and we know the interest rate. So we know the doubling time, ln 2 over k. So ln 2 over 0.084. We'll have to throw that into our calculator. And then we have 11414.71 is P0 e to the 0.084 times the 5 years. right? So same P e to the kt. So this one is actually much simpler than the last one. We just need to divide both sides by e to the 0.084 times 5. So we will get P0 equals 11414.71 divided by e to the 0.084 times 5. We've got to throw that into our calculator. So only the first one of these two really required us to remember anything about how to solve a log equation. All right, so first our half-life, ln of 2 over 0.084, or doubling time rather, so 8.25 years. And then how much did we start with? Let's see here, hold on. There we go. All right, so we need to divide by exp to the 0.84 times 5. And so this is basically saying that we put in $7,500, rounded, right? $7,500, and our half-life, we'll call that 8.25 years. So roughly 8.25 years and $7,500. So not too bad. All right, so next up is exponential decay, but again, we're at the 6 minute mark now. So we will throw that onto the next video.